Okay, so we're going to talk about lesson 9.7, the law of cosines. Yesterday we talked about 9.6, which is the law of sines. And we use the law of sines and the law of cosines when we have a triangle that's not necessarily a right triangle. This is the only time that we can use cosine and sine if it's not with a right triangle. We have triangle ABC, and the lowercase letters, lowercase a, b, and c represent the sides of our triangle, and the uppercase a, b, and c represent the angles of our triangle. And it's important to note that when you do have to draw your own triangle, that the lowercase letter represents the side opposite the uppercase letter. So lowercase a would be opposite angle A, and side lowercase c would be opposite angle C, and lowercase b would be opposite angle B. Okay, let's get to our law of sine equation, and we use these to find missing sides and missing angles when a couple of things can happen. One, we know all three sides, so we have a side, 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 but we don't have any angles. Or we can have side angle side, where we have two sides and then an included angle, which means that angle between the two sides. So either of those cases, we either have no angles or one angle. We can use the law of cosines to help us out and get the answer. Now this is written for a triangle that's labeled ABC. It could be a triangle labeled DEF. It doesn't matter. We would just change up the letters accordingly. The thing important to note is that if I'm solving for, let's say, angle C, then I need a lowercase c out here. If I were solving for angle A, I would have a lowercase a. So let's just kind of look at the actually three different situations. One would be C, A, and then B. So let's say I have a squared equals, and then it would be b squared plus c squared minus 2bc, and then the cosine of a. And that's because we want to end with the angle opposite the side that we started with. I also want you to notice that since I have BC here, or I'm sorry, AB here, I also have AB that I'm multiplying to cosine of C. And then we can do it for the other side as well, the final remaining side, B squared. That just means that we use the other two sides that aside from B. So A squared plus C squared this time, minus 2AC, and then cosine, it has to be angle B here because we started with side B. So those are the different situations. You can use this for any angle, any side. It doesn't have to be the letter C. Okay, we're going to go down and we're going to check out example 1. So example 1 says find the length of side C to the nearest tenth. So what kind of triangle do we have? Do we have one where we know all the sides? Do we have one where we have side angle side? And in this case we have a side and then an included angle for this. And we're going to find side C, which is opposite angle C. So I'm going to write, since I'm going to find side C, I'm going to write that version of our equation down and say C squared equals A squared plus B squared minus 2AB times the cosine of C. Just so I know where to fill stuff in. Again, I want to find C squared, or actually C. I know angle A is opposite, or side A is opposite angle A, so that would be 12. Side B is opposite angle B, so that's going to be 6. And then I would use 12 and 6 also for A times B. and then cosine of angle C, which is opposite side C. We have that. That's 40 degrees. Okay, we want to multiply through. We want to simplify this. I'm going to take C squared equals, that's going to be 144 plus 36 minus, now this is, order of operations tells me I multiply before I add or subtract. So this whole thing stays together. Now we can simplify 2 times 12 times 6, and we're going to do that. And that result is 144 cosine of 40 degrees. Again, this 144 has to stay with the cosine. So now I have C squared equals 144 plus 36 is 180 minus 144 cosine of 40. And then I'm going to go ahead and simplify this part of it and multiply 144 times the cosine of 40. And when I do this, I want to go out several decimal places with my answer. So then now I have C squared equals 180 minus 144 times the cosine of 40 is 110 point, and I'm going to go out like 4 decimal places. The more places you go out, the closer your answer will be to the exact answer. So that's C squared then equals 180 minus 110.3104 is 69.6896, and then I want to take this, I want C, not C squared, so I'm going to take the square root. And I get C equals I'm going to round my answer to the nearest tenth. I get C equals approximately 8.3 there. So that is side C. Okay, now we're going to do example 2. This time we don't have a picture for this one, so I'm going to draw my picture. It says find the measure of the missing side in triangle RST to the nearest tenth if side R is 9, side T is 15, and the measure of angle S is 103 degrees. So just draw a triangle RST, and it doesn't have to be drawn to scale or anything. We just want kind of an idea of where all the parts are on this. So this is going to be R, S, and T. You're going to go around clockwise to fill in the RST, and then you want to know where your sides, corresponding sides are. So your side is opposite your angle. That's side R then. This would have to be side S, lowercase s, and this would have to be side T, and then we want to fill in those values that they equal. So it says R is 9 and T is 15 and we know that angle S is 103 degrees. So this time we have triangle RST instead of triangle ABC. We're still going to do the same thing, kind of concept here. We want to find the measure of the missing side. The missing side is obviously side S. This is the side we want to find. And so the S's are going to kind of take the place of C in our original equation here. So where I had C squared, I would have S squared, that's my lowercase s, equals R squared plus T squared minus 2RT times the cosine of angle S, which is a capital S. And so I can fill that in. Again, I'm solving for S here. R was 9, t is 15. So then I'd have 2 times 9 times 15. And then the cosine of angle S would be the cosine of 103 degrees. Again, important to note that all of this has to stay together. S squared equals 81 plus 225 minus 2 times 9 times 15. I can go ahead and simplify that part, is 270 times the cosine of 103. I'm going to add 81 and 225, that's 306. And I want to get an approximation for 270 minus the cosine of 103. And that is going to be negative 60.7368. It's important to note that we have a minus and a negative and a minus sign, so if we change the sign and add, we would just add those together and we get 366.7368. That's S squared. We want the square root of that because we just want S. And so S would be approximately 19.2. Okay, so we have our final problem. Example 3 says solve triangle ABC if side A is 12, side B is 18, and side C is 7, and we're going to round our answer to the nearest tenth. Now this one's a little bit more involved because it says solve the triangle, which means that we want all the parts. We've got all the sides, we really just need all of the angles. So I'm going to put that we need angle A, we need angle B, and we need angle C here because we just have those sides right now. So you want to draw your triangle, kind of help you out a little bit. And we'll say this is triangle A, B, C. The side opposite A is 12. The side opposite side angle B is 18, and the side opposite C is 7. So this time we have a side, side, side triangle. I'm just going to pick what I want to solve for first. We'll do, let's just start with angle A, which means that when we write out our equation, we are going to start with side A equals, and then we use the other two sides, B squared plus C squared minus 2BC, and then we have to end with cosine of angle A. And we'll fill in what we have. Now because we're missing an angle, we're going to find an angle. Eventually we're going to use that inverse cosine, so that's kind of important here. Side A was 12. Side B was 18, and side C is 7. So we have 2 times 18 times 7 times the cosine of A. I'm going to do a little bit of simplifying. I get 144 equals 324 plus 49 minus 2 times 18 times 7.